Okay, we've got a slightly more demanding binomial example. I'm going to do example 4 and the follow-up example 5, which is based on the same expansion. Okay, but the first part of this is just very similar to the last one we did. Yeah, so hopefully you've had a go at this on your own. Okay, so we've got a number other than 1 here. It's an 8. Okay, so my bracket of 8 minus x, if I just had that on its own, then I could drag out the factor of 8 and have a 1 inside the bracket. But then in order to end up with minus x, I'd need to have minus an eighth of x inside the bracket. But I've got more than that because I've got a power of minus a third. So this is to the power of minus a third. So I need all of this to the power of a minus a third. And of course, the big deal is that that minus a third acts as a power on the 8 as well as a power of the bracket. So it's 8 to the power of minus a third times bracket to the power of minus a third. Okay, so 8 to the power of minus a third. Well, minus powers cause 1 overness, and a power of a third cause fractional powers cause rootiness. So this is 8 cube rooted. So the cube root of 8 is 2, and I've got 1 overness. So 8 to the power of minus a third is a half, which you could do on your calculator if you really felt you had to. Okay, I've only got to go up to x squared, hurrah, so I've only got to do the first 3 things. Okay, you can refer to your formula book if you need to. I've got 1 plus nx plus n minus 1 over 1 times 2 times x squared. So I'm going to put dirty great big brackets here, but I mustn't forget about that half at the end. So I've got 1 plus nx plus something times something. What have I got it for my n? My n is my power of my bracket, which is minus a third. What have I got instead of x? It's not this bit here. I have to look at the bracket I'm expanding, and that's minus an eighth of x. So that's my nx term. And then the next one is n times n minus 1 over 1 times 2 times x squared. Except I haven't got an x, I've got a minus an eighth of an x being squared. And on the top of the bracket, I've got an n, which is a minus a third, and an n minus 1. Take away 1 from minus a third, you get minus 4 thirds. Minus 1 and a third is minus 4 thirds. I haven't put my ... in there, which I probably should do. So I'll remember to do that next. I'm not going to try and deal with that half because I'm not stupid. I'll just do this properly. 3 eighths are 24. So this is 1 minus times a minus is a plus, a 24th of an x. A third times minus 4 thirds is plus 4 ninths divided by 2 is plus 2 ninths. And I've got a minus an eighth, well, minus squared is a plus. And an eighth squared is 1 over 64. So 1 over 64 times x squared. Okay, and now I can deal with the half and multiply all of this out. So half times 1 is a half, plus a 48th of x. Use your calculator if you need to. Oh, the half cancels the 2, so I need to be able to do 9 times 64. Okay, which is going to be 576 or something. But yes, it's legitimate to do 9 times 64 on your calculator. Oh, look, it's 576. So it's plus 1 over 576 x squared plus ... And that's my expansion. Okay, so that was just like the previous example. Okay, but now it's asking you to apply it in a different way. We've now got to expand. Okay, well, I can see an 8 minus x and a cube root of that. Okay, that makes sense. What's this 5 plus x doing? Well, this is not the same thing as this. It's just a variant on that. Okay, so well, what does 8 brackets x to the power of minus a third mean? Well, negative power means 1 overness, okay, and a fractional power means rootiness, and it's a cube flavoured root. So the expansion I've just done is 8 minus x to the power of minus 1/3, okay, all right. So therefore, in order to get this, I've got a 5 plus x on the top, so I'd have to multiply by 5 plus x over 1. Okay, well, this bit is now the thing I'm interested in, but I've just randomly multiplied this by 5 plus x over 1, so I've got to do the same thing over here. So I've got to do 5 plus x on this side. I mean, this is just one way of seeing that what we're actually dealing with, this is just that multiplied by this extra bracket of 5 plus x. Okay, so therefore I've expanded this up to the x squared term, but actually what I really want is the expansion of this whole thing. So the thing I've just done is just an approximation to this bit. I need to multiply by this bracket of 5 plus x. So I need to do 5 plus x times a half plus 1 over 48 x plus 1 over 5, 7, 6 x squared. Okay, but you know what, in practice I wouldn't actually write that down. I would just go straight to the grid that I would use to multiply that out. So I'm doing 5 plus x times a half plus 1 over 48 times x plus 1 over 5, 7, 6 times x squared, and I wouldn't even write that down. I'll just go straight to this. Okay, so I'm doing 5 plus x times the answer to this, which is that expansion there. 5 times a half is 5 over 2. A half times x is a half x. 5 times a 48th x is 5 48ths of x. X times that is 1 48th times x squared. 5 times that is 1 over 5 over 576 times x squared. Well, this is going to be x cubed, so I don't care what that is. Okay, so the grid has done its job. The answer is 5 over 2. Okay, now I do have to combine these. This is 48ths, that's going to be 24 48ths plus 5 48ths is plus 29 48ths. Use your calculator to do a half plus 5 48ths if you have to. A 48 plus 5 over 576. Okay, I think I would use a calculator for that if I had one out, which I have. So 1 over 48, okay, plus, everything's plus, okay, plus 5 over 5, 7, 6, okay, equals 17 over 5, 7, 6, plus 17 over 5, 7, 6 x squared plus dot dot dot. That's my expansion. I haven't done validity. It didn't ask for validity in the question, no it didn't, but I'm going to do it anyway. Always a good idea to think about validity. The formula in the formula book tells you that the modulus of x has to be less than 1, but I wasn't using an x, was I? When I did the expansion I had not an x but minus an 8th x, so the validity is for modulus of minus 1/8 x has to be less than 1, but I want to know what modulus of x is. Well, the minus is zapped by the log, but I need to multiply by 8 to get rid of the 8th, so modulus of x is less than 8 is the validity. Hooray! Okay, but there's more. There's this example here. Okay, now I'm doing an approximation. Okay, the previous one of these, okay, I had to do the approximation of 3.97 and I had to invent my own value of x, but it was a bit reassuring because 4 minus 3 times something small is a bit less than 4, and this was a bit less than 4, so the x value was reasonably obvious that I had to take x equals 0.01. Okay, it's not at all obvious why it's really smart to use x equals 1 over 43 in this. Okay, so what I've got is that, okay, I'm not this answer, it's this bit here. Okay, it's this bit there. So this is my expansion of 8 minus x to the power of minus 1/3. Okay, and it says use it in that expansion, not the final expansion we got. So that's the bit I'm using. Okay, so actually let's write that down. So 8 minus x to the power of minus 1/3 we know is approximately a half plus 1 over 48 x plus 1 over 576 x squared. That was my original approximation before I went on and did clever things with that other bracket of 5 plus x. Okay, so it tells me to consider x equals 1 over 43. Now the tempting thing is just to substitute x equals 1 over 43 into this and say that must mean something. But actually, it's a good idea always to start with the exact side, not the approximate side. So when x equals 1 over 43, what does 8 minus x to the power of minus 1/3 equal? Okay, so it's 8 minus 1 over 43. Okay, to the power of minus 1/3. Okay, well, what's 8 to the power of, what's 8 minus 1 over 43? Okay, again, your calculator can do that. Okay, go on then. 8 minus a 43rd. 8 minus 1 divided by 43 equals 343 40-thirds. So this is 343 40-thirds to the power of minus 1/3. Okay, but what's the power of minus the third do? Well, negative powers cause 1/ness, but for fractions that means they flip the fraction. Reciprocal of a fraction, you turn it upside down. So it's 43 over 343 to the power of a third, which is a cube root. Okay, so that's what the expansion is telling me. All right. Oh, but 343, have I seen that? Let's just think about the cube root of, so the cube root on my calculator of 343 is exactly 7. 343 is not just a random number. It's the questions have been fixed to make this really nice. This is the cube root of the top, which is cube root of 43, over cube root of 343 is 7. So the cube root of 43 over 7 equals, okay, so I've taken x to equal 1 over 43, like the question kindly told me to do. So if I've done that on this side, I need to do the same thing on this side. So it's approximately equal to a half minus 1 over 48 times 1 over 43, because x is taken to be a 43rd, plus 1 over 576 times 1 over 43 squared. Okay, it's approximate because I've missed off the x cubed and higher terms. Okay, so notice it isn't directly telling me. I want an approximation to the cube root of 43, but the series is telling me the answer I want divided by 7. So I'm going to work this out, and I'm going to get that as a decimal, and then my last step is to multiply it by 7. So I've typed all of this into my calculator. You can't see it all, but it is all there. Press equals, and it resorts to decimals. It gives me 0.49951644428. But that's not my final answer. That is my approximation to the cube root of 43 over 7. So therefore, the cube root of 43, okay, is approximately 7 times this answer. So I need to take this, I need to do that times 7, okay, and I get 3.4966151. 3.4966151. And that is my approximation, okay. Again, on this type of question, I recommend giving lots and lots of decimal places. Let's see what the exact cube root of 1 over 43 is. So the exact cube root of 1 over 43, well, it's not exact, but it's a better approximation. What have I done wrong? Oh, it's the cube root of 43, not 1 over the cube root of 43. Fool. Go away. 43 equals 3 don't believe you. Cube root of 43. I've done it wrong. Oh no. Bastard. What have I done wrong? Okay. What's nice, it says built-in checking going on. Oh, I've copied it out wrong. This 1 over 48 was a minus 1 over 48. Well, I copied it so no, that's a minus. Okay, so when this goes wrong, you found you've got a sign error. All you've got to do is check it through really carefully. So this is still a minus, but this term here should be a plus 1/48 of x. So that should be a plus. Okay. Oh, so this is all garbage, but I've still got it on my calculator. That's all right. Okay, so go back here. Go back 2 lines. Okay, where is it? Okay, change that minus to a plus. Aha! Okay, so this was garbage. This should have been 0.50048543551. So what did I have to do to that? I had to multiply by this 7 to get my answer. So times 7 equals 3.503. So 3.503398045. Oh, I've written it all down. Okay, so that is my answer for the cube root of 43. And if I actually did it just now, didn't I? that was the exact answer from your calculator. And you can see this is even more astonishingly close than the last one. Instead of ending 4, 5 here, it ended 6. Okay, so look, okay, so I made a mistake there, didn't I? I did what you guys often do, which is copied a sign wrongly. We try not to do those things, but it's just a simple check I did at the end to check with the exact answer. And it was fairly easy to find the error, and then I was careful about tracking it through. Okay, so I'm not going to redo the video, partly because I'm really lazy, but also partly because I want you to see that you can make an error, okay, but then build in sort of checks that are going to help you find that error and get to a solution that may be trifle messy, but we don't care about that. We've got the right answer. That's our approximation. Okay, so we're happy. I hope you enjoyed that video.